All right, let's talk about the difference between function composition versus function decomposition. Let me start with a simple composition example, because to know how to decompose, you first have to know how to compose two functions. So I made up a couple of functions, f and g, and my job is to find a third function, h of x, which is defined to be the composition f of g of x. So if you look what's basically going on here, g of x is a function that takes numbers as inputs and adds 3. That's all it does. F of x is a function that takes inputs, x, and squares them. This notation says we're going to apply one function, then the other. In fact, with function composition, we always do the inside function first, which means we were going to apply the function g of x first, and then the function f of x second. So what's going to happen is you're going to plug a number into g, it adds 3, whatever that result is, you're going to now apply f of x, the second function, and f of x is going to take the number you got after adding 3 and simply square it. So the idea of function composition is to take those two functions and write them as one. I want one function that does the job of applying g of x followed by f of x. So in a minute I'll show you how you can find this by making a substitution with the notation. But let's be clear from the beginning that if you want a function that adds 3 and then squares, here it is. This is going to be our function h of x. Since it's different than f and g, we had to give it a new name. So right here we're just saying let's call that new function h. So the answer to this problem is going to be h of x equals x plus 3 squared. It's a function that when you plug a number into x, it adds 3 and then you'd square it, which is exactly what you'd get if you took a number and you applied g of x and then f of x. G of x would add 3, f of x would square that result. So here's one way to explain how to manipulate the notation so that you get that result. One way is to start with the outer function f, the one that's going to be done second, and realize what f is. F is a function that says whatever you plug in here, we are going to take that value x, notice it's in both places, and whatever you plug into me, I'm going to square it. That's my only job. But the problem says we're plugging in g of x. We're putting in g of x here. But if you replace g of x with what it's defined to be, g of x is defined to be x plus 3. So we're just saying, hey, g of x is x plus 3. And here we have g of x again. We'll put x plus 3. So if you remember that function notation means that whatever is in the parentheses is the input, then what we have right here, if you line that up with f of input, means that g of x, the function g of x, is going to be the input into f. That's the thing you're plugging in. So there's always two things going on. There's always a substitution being made to a function and what's being substituted. This notation says that we're going to apply the function f. We're going to take something and we're going to square it. What are we going to square? Well, you have to look in the parentheses to see what the input is. We're saying that we're going to input g of x. So this is what we're plugging in. So that is what's going to go here, and it's going to be squared. So it turns out that f of g of x was equal to this notation, but we found that notation to be equal to this. So in summary, f of g of x came out to be x plus 3 squared. Like I said before, because x plus 3 quantity squared is not the same as any of the two original functions, we had to give it a new name. But in the end, this new function h does exactly what g and f would do if you apply g first and then f. So let's take this exact example and talk about function decomposition, which means instead of taking two functions and putting them together, and hopefully this makes sense that we did put them together. We had a function that adds 3, and we had a function that squares. We turned into this function, which is a function that takes numbers, adds 3, and then squares them. Decomposition would be the reverse, where we give you the composition function, and we tell you one of the two functions. So suppose we didn't tell you what g of x was. That is what function decomposition is, and it would ask, you tell me what function would I have to put right here? What would I have to put in the parentheses here so that when I square it, I would get this result? So let me go down and show you how that would look. Whenever I explain this example, I always argue that the answer to the question is actually really obvious. It's understanding what the question is asking, which is difficult to understand. But if you know what function composition is, hopefully this will seem easy. So this is the piece right here that's going to drive the question. This says that we're going to find a function h, and the definition of how we're going to find it is we're going to take g of x and plug it into the function f. So if you look at what f of x is here, it is defined to be x squared, which means that whatever you plug in here, you have to take that same result and square it. And usually what I do is I just leave a set of parentheses here to indicate whatever goes here. And in math, we put a variable like x to denote that. Whatever you put here also goes there. But you could also think of it as fill in the blanks. So for example, if I asked you to find f of 7, you would say that's 7 squared. In this case, though, we're not plugging in a number, we're plugging in another function. And because we're decomposing it, we're saying that we're not going to tell you what the function is. We're just going to tell you that its name is g of x. That's what h of x equals f of g of x means. Now I'm going to fill in the blanks. The question is to find the function g of x, which is the function you're plugging into f, which means whatever you put in here is the answer to our question. They're telling me that whenever you fill in the blanks and you get f of g of x, the answer will be, after you compose it, the answer will be this right here, h of x equals x plus 3 squared. So they're saying that the answer must be this. Well, look, the answer is a function that adds 3 and squares things. So we need two functions. We need one that adds 3, we need the one that squares. And so far, all they've given me is the function that squares things. So I'm missing the function that adds 3. So the answer should be pretty clear. They're saying, please put something in this blank here so that when we square it, you get this answer right here. What is the function g of x so that when I plug it into f, put it right here, well, I get this result. So the only way I'm going to get this result is if I put an x plus 3 here. Then I would have this result, and if the answer is x plus 3, that means that the thing I'm plugging into f, which we're calling the function g, must be x plus 3. So basically we broke this into two pieces, whereas the first example we put it together. In the first example they gave me the two functions I was to compose and told me the order in which to compose it. They said take g of x and make it the input into f, which meant take this function, this is the definition of g, and it becomes the input into f, which means replace the input variable into f with that stuff. And if you replace x with x plus 3, we got this answer. We put it together. We took a function that adds 3, we took a function that squares, and wrote it as one function that does the same thing. It adds 3 and squares. So function decomposition is the reverse. We give you the answer and ask you what the two functions must have been that someone composed to get it. If that's not clear, let me show you one more. Here's one more example, and these can be very quick once you know what you're doing. Here it says h of x is defined to be f of g of x. This is important to know the order in which you're composing. Since it's f of g of x, that means that g of x is the input into f. Function notation always is f of input. Whatever is in here is what you're plugging into this function here. So that means whatever you find as your answer is a function that's going to be substituted into the function f. And this is the guy where you make substitutions at. That's what this notation right here means. So what is it that we put here so that when someone replaces x with the junk you wrote here, you get this answer? Slightly more sophisticated, but you can kind of think of there's two functions going on. There's square root involved, so we need a function that does the square root, and they gave it to us. They said f of x is the square root. But there's another function that's going on that's a little more complicated. It's a function that takes numbers x, multiplies them by 2, and then adds 3. So that would be another function. This technically could be broken down into composing even 3 functions, because there's actually 3 operations. There's multiplication by 2, there's adding 3, and there's square root. But in this problem, they're obviously only dealing with 2, f and g. So the idea now is, since h of x is f of g of x, that means, what do we plug into f to get this answer right here? But remember what f of x is. F of x is the square root of x, and you make substitutions into a function right here. You replace x with some number or something. If I said what's f of 7, you'd say it's the square root of 7. But the idea is, even though the rules remain the same, we're not going to plug a number in, we're going to plug in the function g of x. So the idea is, I need the answer to be the square root of 2x plus 3. They gave you the answer in the beginning of the problem right here. So that means I must define g of x to be 2x plus 3, so that when someone plugs that into f, I get this answer. So if you're good at function composition, function decomposition may be very clear. You just have to identify where is it that something's being substituted in. That was given in the part of the problem that said h of x equals f of g of x. It means that you're applying the function f, and then the thing in here is telling you what you're plugging in, which means give me the function g of x so that when someone plugged it into f, they got this result. So once you get good at this, these questions should be relatively clear. From the beginning, I knew that I needed a square root function because there was a square root in the given problem, and I also needed a function that multiplies by 2 and adds 3. So we just defined a function that multiplies by 2 and adds 3. We defined g of x to be 2x plus 3. So that when one got plugged into the other, we got the desired result. Hopefully that helps you understand the difference between function composition and function decomposition.